Mark, I had a question. I had the impression that our ability to have online meetings in the past couple of years through the pandemic has fostered better participation in foreign countries, smaller countries. Is that true or not? And are we going to lose some of that participation when we go back to primarily meeting in person?
That's a great question. I think it's, as the webcaster, as a person here, I think it definitely has enabled practical participation from a much more diverse group. And so that I think is a great thing for the community. I don't know if that's necessarily going to be something reflected in these charts, because again, it's about whether you actually sign up and renew if you get counted there. But personally, I think anything we can do that gets the message of what we're positioning out there and gets more people active and involved and thinking about it and talking about it is a great thing.
Well, now that you're there with David, and David's an expert, of course, in hybrid meetings and online things, how difficult would it be to continue having hybrid meetings? I know it introduces more complexity. We saw that in our subcommittee meetings as well.
I mean, as far as what I'm doing here right now, I mean, you know, this only took about 30, 45 minutes to set up, right? You know, with more pre-planning as far as telling everybody, you know, like what we're going to be doing and kind of having this be the dry run of doing this, like to be able to do this again at our next meeting in Stavanger, is that correct? You know, there's that possibility to be able to continue doing that and being able to get, you know, that broader audience to be able to attend and be able to watch. So it's not insanely difficult, right? And you know, my personal belief, right? I think it's worthwhile to be able to do like what you said, do the other countries and other places involved.
But just another side is that when we did the online meetings, and for the first ones, we were charging a minimal amount. And I think the highest number that we got was like 77 people. And then we decided to do the previous to this one free, just to allow anybody to join and not even commit to. And then we got the lowest turnout. I think it was like 55 people. And so it makes sense, but somehow it doesn't work. And I think so that's why we decided to do it in person, and we have about 90 people here. And I think it's a good experience. And with the other one, we didn't feel that was necessarily a good experience. And the fact that we opened the door to everybody to join, even for free, and we announced it as much as possible, and we didn't get the numbers that we were expecting. So we met the reality there.
Mike Ashall, Case Directional. Just a comment on the in-person versus virtual. Speaking as someone involved in a couple subcommittees, I just want to make a comment that, like, outside of these walls is where the real work gets done throughout the year in between meetings. So, and that all does happen virtually for the most part. You know, these cups of different people from different parts of the world. So there is often need to be involved and participate even outside of these meetings. But I do agree that it helps a lot to have this exposure. But if people want to be involved, there's a lot of opportunity for that virtually.
Sorry, thank you. I just want to give a feedback on based on the distinguished lectures, our experience. And SP, they decided not to do online anymore. It's better to do in person. It costs a lot for SP as well, but that's the route they take. I just want to share this with the group. And even though in some cases, you know, they invite me to do the online, I said it's too bad, man. I'm not coming. I will collect all the schedule and I will make a trip, you know, separately. That's the feedback I have. Okay. When I do online and then you have to translate in Russian or in Spanish, that's the worst disaster we ever get. Okay, I can tell you that.
Yeah, and I think that is a key thing where the online as a supplemental experience is definitely valuable, getting the message out there. But having everyone in the room is important. Things like voting that are about to happen right now are probably going to be things that we still need to do in person to the extent we can. And honestly, I think a lot of folks, when we did the online experience, it was tougher to, for lack of a better term, justify the commitment to like your coworkers and stuff. Like, oh, I'm here at my computer and I could answer a call, but I'm supposed to watch this 4-hour webcast.
Yeah, and
it's hard to be present and active the whole time.
Put on mute, camera off. going somewhere, right?
Yeah, thank you for the update, Mark Johnson with Oxy. My question is really more about the demographic of the industry, of the members for SPE. And I went to the geothermal technical section social the other day, and they talked about their membership numbers are already up to 1,800 just for geothermal, which is a technical section now in SPE under that group. And just curious with other industries, do we have any way of knowing, what these folks, sequestration, geothermal, HDD, any river crossing and pouring and trenchless work, or is it all on oil and gas? That's all under SPE. Is there a way to maybe, in the ISCWSA website, where if they're not an SPE member or don't consider themselves, really focused on petroleum engineering, but more other types of minerals, lithium extraction, anybody that bores holes in the earth probably needs to know about some of these things. Is there any way to drive some of that membership in getting those other industries who are navigating well subsurface into knowing more about this stuff that we talk about?
Yeah, I think there's definitely opportunities to reach out and connect with those other industries. Tracking them in terms of membership numbers and things like that might be tough. All of these charts are through the SPE because it's the SPE technical section. Trying to track it through ISCWSA website registrations might be a little tricky. And I know that for a while there were some challenges actually getting registered on the website, but that should all be past us. But I think it's less likely we have folks who have found us from those industries who are active that we don't know about. But if we reach out to them, we can try to attract them. I think we're at time.
If they download the ebook, maybe they can just say what industry they work in.
No, that's an interesting idea. Yeah, absolutely. So then you'll realize that I have to download the ebook once a week because I've lost my old copy.
All right, thank you very much.
Is there a PowerPoint for it?
No.
Oh, okay.
So now we're gonna try to conduct the election. So I guess I hope you have a chance to read the candidates that were on the table. Let's start by the order that we have here with the treasurer. So we have David Erdos and Robert Wiley. So common practice is to ask these folks to leave the room, so we do the vote. And then we'll do it with the raise of hands. And as I said before, let's try to limit the votes to three per company. And so we don't have a skew election. All right. So raise your hand for David Erdos as a treasurer. Okay. For Robert Wiley. Okay. So we have
Karen, can you call him back in?
all right. So
Use it.
yeah. After the vote, Robert Wiley has been re-elected to the position of treasurer. So congratulations. Thanks, David, as well for participating. For the secretary, there was only one candidate team for re-election. So as there is no other candidate, we don't need to vote. We just team will continue with the role for another 2 years. We need to
Make sure there's no objection.
Any objections? We'll take laughing as a yes, so Tim,
yeah, I'm not sure that's both, but next one is Phil Harbich for webmaster. as well. There is no other candidate for that. So unless there is a strong objection, we'll move on with that. Okay?
All right, congratulations, Tim.
So for the next one, we have 2 open positions and 4 candidates. So as it says here in the paper, we're gonna vote for 2. So we're gonna ask Apremaya, Carol, Joel, and Mahmoud to step aside, and then we'll do the vote. So yeah, let's, it says here, pick 2 candidates and we'll vote and count the votes at the end and see who are the 2 with the most votes. All right, so for Apremaya, raise your hand. Okay. For Carol Mann,
All the way up there, so especially if you work with
all right? So lower your hand. For Joel, raise your hand. Got it?
I don't know, you guys don't know how to keep your hand up long enough for people to count them, so
And
it's kind of like burning your vote, so.
for Mahmoud,
Well,
yeah. Okay. All right, I think we got the numbers.
so I got.
Yeah, yeah. we got this one. Can you?
Oh, yeah, I guess so.
okay.
Carol's not here.
David is a good entertainer. That's fine. So Carol and Mahmoud have been re-elected for the role for another 2 years. So congratulations. And that finishes the election for this time.
So next up, we've got. Oh, Mahmoud. So next up, we've got Mahmoud with K&M for continuous collision avoidance monitoring using definitive dynamic surveys and passive magnetic ranging.
All right. Got this. Okay.
Thank you. And thank you for re-election. Really appreciate it. So you can read the title. It's a pretty long one as well. So we have this paper. It's will be published next month. So it will be available in Petro One end of end of this month, because this will be presented at the ADIPEC in Abu Dhabi. So this paper, I have Mark Fraser, Ross Loudon, and Jimmy Lurie, co-authors. And in fact, in this presentation, I'll have Mark will come up to talk about the results later on. And what you see the title here, this is collision avoidance monitoring using definitive dynamic surveys along with the passive magnetic ranging. So the standard way today to avoid collision, you guys, all of you are aware of it, expert in this one. The way that we avoid collision today, we take the survey firsthand, usually, and calculate the ellipse of uncertainty based on the tool that we run, based on the environment that it runs in. We have the ellipse size, and we do the same for the offset well as well. So we have two ellipses, and based on these two ellipses, we calculate the separation factor, right? And the separation factor is the ratio between the center to center distance between the two wells divided by the combined uncertainty between the two wells. And yeah, so this is a conventional way. Like this is how everybody's doing it. It's very safe. Typically, there isn't a single collision occur due to using this. So this is no issue with this one. So in reality, the ellipses that we have, the size of the ellipse that we have, the well can be anywhere in this. It could be on the far left or the far right or probably in the middle. So we have a lot of region, a lot of part of the reservoir that is untapped. So there is in some applications, we might need to go and drill in this region of a high risk of collision. Several reasons. One of them that I just explained, that this is like infill drilling. You have your ellipses touching, and now you said I'm not gonna drill any closer because of the collision risk. But what about your reservoir production? What about all the other aspects? And in some situations, you need to drill closer, and this is some of the examples, some of the applications. Infill wells, you need to drill closer, even though you have a collision risk, but you start to think of ways to get closer while monitoring the collision and avoiding to collide with the other well, even though we're using the separation factor. Replacement wells, frac recovery, slot recovery, carbon capture, the top sections, top hole congestions. So these are the situations that we want to avoid colliding. Other applications as well. This will be on the other side when we want to intercept for relief well, for example, and like PNA and re-entry. We really want to intercept at a specific interval, at a specific formation. And we really want to avoid a premature interception. So this means we have to get close to the other well, and we have to enter this zone of a high risk of a collision, even though our objective is to intercept, but not here, later on. So this, one way to do it is to monitor how far we are from the other well and range to it. How do we do it? Passive magnetic ranging, typically the most common one, most economical one that is used. Vinny touched on it in the morning, so I'm not going to spend a lot of time on it. But just the takeaway from this one, it's done using any MWD tool, most of the MWD tools out there. You collect the measurement, you process it, and it gives you, you take a certain number of surveys, and it gives you an idea of the direction and the distance of the offset well, given that it's cased, then you get an interference from the cased hole. So passive magnetic ranging has been around for some time. It's nothing new. This is not what we're presenting today. And it falls like two categories, like two aspects to the passive magnetic ranging. One of them is monitoring, the other one is ranging. What I mean by this one, there is one aspect where we take a survey per single or a survey like by mid-stand, just to check for the external interference, just to as a detection, to tell us if there is interference or not. It does not tell us anything more, but to give us an idea if there is interference or not. Could also be done for some MWD tools that logs the continuous magnetometer data along the axial. So we take this data as well, and we give us an indication. It measures the magnetic field. And like I said, it doesn't tell us where and where. Like it doesn't. This does know the direction of this. When we want to do the ranging, we have to take a stationary surveys, 5 to 10 stationary surveys. This is when we decide, okay, now we want to know the distance, we want to know the direction. So what we do, we take somewhere from 10 to 15 stationary surveys. And this is how it's done today. What we're presenting to you today is how we are taking advantage of the continuous 6-axis data while drilling. Why? Because now to take this 10 to 15 surveys, you have to cycle the pump every time. So that there is a rig time involved. The borehole conditions, if you have any borehole conditions due to the cycling the pump like 15 times in a very short interval and in a short time, it could impact your borehole. So in order to overcome this, and we are utilizing our definitive dynamic surveys. And for those of you who are not familiar with it, this is a next generation MWD tools out there. It takes surveys on the fly. We take a survey every 20 seconds and it's stored in the tool. We get it pumped up pretty much every 2 minutes. We can get a survey. And when I say we get a definitive surveys, we get a 6 sensor data with a QC or the full QC parameter, the same one that we are used to do with the field acceptance criteria. This is done on the fly. This is what gets pumped up, QC'd, definitive survey that we can use. And in order to do this one, it's there is a lot of challenges because we've been since inception of the MWD tool. All of us, we know that we need to stop drilling to take the survey, especially surveys. This is all changed right now. We don't have to stop to take the surveys anymore. We run this tool and we take the surveys all the time on the fly. We're able to handle this one by having a high sensor sampling rate, processing speed, increasing the memory, improve environmental corrections to enable this process. Also, the upgrade and the changes in the hardware and the firmware to handle the shocks and vibration and the stick and slip while drilling allows to come up with this accurate definitive surveys. So now what we're doing here and what we're presenting to you is utilizing we're drilling all the time, we're collecting the definitive surveys all the time, and we're using this one for the passive magnetic ranging while we're drilling close to the other one. How much of the rig time that we spent? 0 rig time. What is the value? We will show you the result of the case study that we're able to detect the other wells. We're able to come up with the distance and the direction of the other one. And in this case study here, we picked a specific like platform where we're drilling in batch drilling, and we looked at the data from the top section. And this is a 24-inch section. We're drilling 6 wells in batch drilling, so we 24-inch skid the rig, drill the second well, well 2, and then the well 3, well 4, well 5. So this one, we know the position approximately. We know the position of the other well. We know the surveys, and now we're gonna do the ranging, and we're gonna compare to the surveys that the position that we think it is. We have another challenge. We have an environment with a multiple wells to look at. With this, I'm gonna turn it over to Mark to walk us through the result of this interesting case.
Thanks, Mahmoud. Right, so for those who don't know me, by the way, my name is Mark Fraser. I've been with SDI for 33 years and been involved with ranging for probably about the last 15 years. So this is the setup we have here. We drilled, and it's the drilling sequence is there as well. It's a multi-well environment, which adds to the complexity of the ranging. So at each once the second well was started drilling, we started processing the ranging data, and then did that for subsequent wells as well. So this is just to explain what's going on here. The blue well is the well we're drilling. The green well, in all of these scenarios, the green well is the one that we're actually ranging to, or where our ranging results are the closest to. The plot in the bottom corner is the magnetic field as measured by the MWE tool, and the table on the top right has the ranging results compared with the surveyed center distance and direction. Now this is a very good quality magnetic signal from an offset well casing string. We've got 18/5/8 96 pound per foot casing, so it's a big, strong signal. It's new casing, so we would expect to see something really strong. We took four ranging results there. We're trying to compare them with the combined uncertainty of the two wells. So I had a bit of difficulty putting that all onto one well. So you've got to kind of expand the green ellipses a bit. The pink sort of trapezoid shapes are the ranging results with uncertainty. We got really good correlation there with the ranging results, which you would hope to get with that type of signal. On the third well, we had the added complexity of having an extra casing string in there. The signal is not nearly as clear, and in fact, in a certain part of that, for about 200 feet, the well distances were very close. But we still managed to get really good comparison for 6 ranging results during that run. Adding a fourth well, we got two ranging results out of this, and again they were really good comparison. What we found as well, we didn't interfere with the drilling operation, so they were drilling just as they normally would. What we like to see when ranging is good data density. So if you're drilling too fast, you can end up with not close enough spaced surveys. This affects the ranging results. So what we would often prefer to see in these scenarios is maybe control the ROP once you're in that sort of collision risk area, so that we get enough data for good results. Again here, we've got 3 ranging results with 4 offset wells. Still, really good comparison with the center distances, and all within the combined uncertainties. The ranging, the data density is a bit more sporadic here. They seem to be drilling quicker, but we're still able to get sort of pretty good comparisons. And then with the final data set, we actually were able to range on 2 different wells. Once here in a multi-well scenario, it is possible to range, even though there's a sort of combined magnetic signal, as long as one well is closer than the other. And what we found was that in this situation, with the survey position, the well 5 was closest, and then well 4 crossed over, it became closer in the deeper section, and that's exactly what the ranging results showed us. So just to conclude from that, the quality of the dynamic sensor data was very good from a ranging perspective. We were able to get good, clear results. Ranging looked looked very good and consistent with survey positions and with our combined uncertainties. We used no extra rig time. There was no actual discussion with the rig. We just took the data as we got it. Ranging can be performed in the background while drilling, can be analysed for every magnetic pole we see, and then results provided. So typically when you're doing this, you would have to stop at a point, take, as Mahmoud said, 10 to 15 surveys, spend a bunch of rig time, hope you've got over the magnetic pole. If you haven't, you take more rig time to get over that pole to get one result. This way you can get results continuously. And pre-job planning is vital actually in this instance because you need good data density. So typically with ranging, we do a lot of pre-job planning to get that. So you might have to limit ROP in certain areas when you need to get good results. Most of you guys will probably be aware of this, but there are still people out there that think this will eliminate the need for gyro surveys. It's absolutely not the case. You don't get a definitive survey, and you don't. In low angle sections, you need the gyro survey to get good orientation. So we just focused on the collision avoidance scenario, but there are many other applications for this. In relief wells during the forward phase where you don't want to spend time tripping and running wireline, especially if you have a deep intercept. For SAGD wells, running magnetized casing can often be beneficial, and using this method, then you won't need to stop to take ranging data. And similar to relief well drilling, where we have complex abandonments and the formation is particularly unstable, then there's no requirement to stop, and you can get ranging data throughout that formation. Thanks, that's the end. Any questions?
It's handy when you stand or sit beside the person who's the mic runner. Thanks very much for that. Really interesting presentation. And I don't know who answers this one. It was apparent that you were ranging for the last well. So what point was the well ordered? Was that pre-planned? Was that a concession to the need for passive energy ranging?
I don't think there was any order. It just happened to be the closest well. Usually the last well was the closest well. I don't know anything about the order of the wells.
Hi, Bethany. Don't be afraid about that. But the question actually comes from something that I've wondered for years and something we've struggled with in a prior life. Was about when you do talk about ranging underneath a platform, right? That you it's anticipated that it would be difficult because you would have sort of the approach of ghost wells. A well is that when you're trying to range the combined magnetics of multiple wells with a good position of something that really exists. And then I was looking at those really interesting. For 1 and 2, I saw that you had very regular ranging stations, but then as you increased in density, I saw that you were filtering out a lot more stations. Was that because you were seeing things that didn't make sense in the proximities because of the influence of the offset wells?
Generally, yes. It's a lot more complex. The signal's not so well defined.
You know, and that's something that we've been,
Yeah.
that, we always, meaning not the federal government, meaning when we were looking at these projects, trying to understand, could you actually even get underneath the facility to drill a relief well? Because you may never be able to find it. And that's what I was wondering about that. It's really interesting. I would love to see if you would ever able to share it for my own personal curiosity. What those stations look like in between that y'all dropped out, to get an idea of what because again, it was a theory, we thought we would see it, we've seen it on other cases, but having it measured like this would be very, very interesting to understand. How would you want to even determine that you weren't looking at something real? Because you don't have the luxury of seeing those points passed until you post one after you've passed those points. So how would you determine that maybe perhaps that point was not valid? So I'll finish and stop my participation. It's actually very interesting.
I think a good byproduct of this is the amount of data we received in a multi-well environment.
Yeah.
And we haven't actually really looked at that data, but it's a good, it's a good starting point. Yeah.
Mike Actual, case editor, professional. I have the same question as Lisa, so thanks for asking that. So I guess a follow-up question, and maybe kind of already answered this, like, how do you qualify the surveys? Because this came up in the air model meeting yesterday. The answer is kind of like there's a different way that it's done, but kind of similar. So maybe you can speak, one of you can speak a bit to that, how to qualify the continuous surveys, especially within a passive ranging context, but just even in general.
Okay. So how do you qualify the stationary surveys?
Survey knowledge, all of this?
So the stationary surveys, how do you qualify?
Well, you're stationary, so you get a good survey. If you know you're not moving, there's no other influences to that.
So how do you qualify? You look
Well,
at
it's
the
up to criteria.
Exactly, and that's exactly what we do here. We do the same, right? So we get the 6 sensor data, we get it up, it's pumped up, and we look at the field acceptance criteria, the same ones that you look at for the stationary. We look at the total G, we look at the total depth, and we look at the total magnetic field as well. Similar criteria, and we qualify. And this is the easiest way, right? So anything that you do with the stationary surveys, when it comes to qualifications, is done there.
But I mean, the raw data that you're getting that's run through the tool system to come up with some, I'm assuming like some sort of average value, like the rotational.
Yeah, it's filtered out, but you end up with the same 6 sensor data, the same one as you get from the station, right? And you do run the same qualifications. Physics are the same. It's just a different environment that we try to filter out the noise and subsidization around based on the rates that we have in the firmware and the hardware. But by the end of the day, the same as the stationary, you qualify this one the same way as you do the stationary.
Sorry, I'll talk loud, you don't know. How do you qualify if you've got offset magnetic interference? I think is
The other question is, we've got offset magnetic interference, you can't use total zero for depth now because it's influenced by something that you can't predict, that's why we can't use this for good magnetic surveys, right?
Sorry, can you repeat that?
You just said you would use the same qualifications you would do for qualifying a normal magnetic survey, which you'd be looking at your reference fields. How can you look at your reference fields when you already know your reference fields are perturbed from your offset wells? That's what's allowing you to range.
Okay. So that's a good point, but maybe I need to clarify. He's talking about the question about the dynamic surveys in general, like in a clean environment, right? So that was the answer to this one. And in a clean environment, that's the stationary. How do you qualify versus the stationary one? Now to move on to this situation that this has already been qualified as a definitive dynamic survey for the last couple of years. Yeah, in so many years. Does this answer your question?
There's also gyro.
Yeah. So
GWE, right? So all the surveys are gyro.
So the first part, qualify if there is no interference, we get this is done. Now we have interference. So you have this signal that you see there. And for any ranging expert, we can look at the signal and we can see. Now the qualification is not about field acceptance criteria. Now I have an external interference. We must have the external interference in order to be able to range, right? So for any ranging expert, if you look at the signal, then we'll be able to if there is a pattern, you can see the pole, range for the pole, they're able to take it further and come up with an analysis to come up with the distance and direction. When there is more than one wells, it's probably distorted. You will not have the nice of the shade, it's going to be distorted and probably going to be just garbage, different signals. Unless you have one dominant offset well with a casing that is nearby that has a signature that you can analyze, it's just going to be garbage.
Mark HMP. You talked about the difference between monitoring and ranging at the beginning. I was curious if you made any attempts to try and put like peak detection in cool firmware or something to where you might not have to worry about data density being pulled stuff whole. You can just almost like a vibration warning, but for a close approach warning, like if you're detecting these swings and magnetic.
We don't have, do you want to take this one?
I'm not aware of anything happening with that. That's a good point, though.
Yeah, it's a good point. We don't do it. We don't have something yet, but we just got this tool out just a couple of years ago, and we have this as an answer product. That's probably always complete.
Consultation for this kind of use. Thank you for the presentation. Very interesting. A little bit familiar with DGS. And my question is two questions actually. One is what is the minimum distance of this approach, because the sensor are going to be saturated with the second one, why you don't use deep, the additional channel of information, because it should give you more information and improve your tracking accuracy.
For your second question, I just use that as an example. We use the 6 sensors for ranging. We all use all 6 sensors to make accelerometers. So I just, I didn't want to put the plan, too many faults out there.
Okay, and what is the minimum distance of this approach?
You can range up to the point where the sensor is saturated. So I don't know what distance that would be. It just depends on the case and weight. I think it just depends on the case and weight and the neck, pull strength, range, joint.
I can tell you the maximum. I can answer the maximum maybe.
Maximum it's pretty clear, but I mean it depends on two threads. But my point is that if your distance is, minimum distance is 2.5, is it any sense to use the technique? Because you'll be far away. But if you go closer, your sensor saturated, and you cannot use this technique. That's all.
Well, that's clear. Your point is clear. If it's too close and too saturated, and you're not getting a pattern, you will not be able to use it. That's clear.
Yeah. And my question is, what is the distance when you cannot use it?
We don't know the distance.
The maximum distance for detection is for this. Minimum is as close as it is when too saturated. So that,
You know the number? The minimum?
it depends on the casing weight. For that casing weight, probably a foot or two away. Off the top of my head.
Hi, Clint McGon. This is a great presentation, and this is for sure the way the industry needs to go. While doing. Quick question. I'm thinking, how would I use it? Not trying to, understand it yet. But now I'm using it. How would I use it? So what's a sensor? How close can we get to the bit of? That's really what's really cool, right? Where are we making the measurement? What was that? Pretty close to the bit, right, Mahmoud?
Yeah, well, it's as similar as any MWD, right? It's pretty similar. Whatever you're gonna fix your MWD.
So like a standard, let's say.
Yeah, it's exactly. It's exactly the same.
That's a
So,
great.
thank you.
Mahmoud, Robert Estes at Halliburton. The minimum distance also depends upon your proximity to the casing column. So for instance, mid-body of a casing joint, you could get much closer and still have accurate ranging. Is that correct?
Correct, and that's the answer that we don't know exactly because it depends. And we need to look at casing size, of course, like a lot of factors. You cannot just come up with a number.
But for instance, for a designed interception, you might intentionally aim for the mid-body of a casing fluid rather than direct solid.
Certainly, yeah,
At least avoid the saturation problem.
certainly, yeah.
Thanks, still being fun. I'm picking up on Clint's question. If you had a rotary steerable which had a 6-axis system, could you use that for passive ranging?
But we don't.
Where would you have?
It will come soon, maybe.
Todd, away with the North Dakota oil and gas building. Very good presentation. I guess I've got a couple quick questions. First, one of them got answered, censored a bit, so I appreciate that. So what contractors are using this, this definitive dynamic surveys? Is it primarily Schlumberger right now, or is there other contractors? And then where is this being used? Is it used in the States, or is it used in other countries? And what if it's only used in other countries, when is it coming to this state, into this country?
It's a new technology developed by Schlumberger, and currently only Schlumberger that provide users. It's not run in the US very often. It's typically when the technology comes out, it goes to like maybe US land, maybe no. Deep water, Gulf of Mexico, Alaska, that's probably yes. So it's been run all over the globe right now. Not for this application in particular, for the passive ranging, but it's just trying to save the rig time and to have more surveys on the first hand.
Then you bring it back, Photo. I know in a situation where the tolls on the different wells, can you put back the figure? The tolls are on the different figures.
Ask your question earlier.
Yeah, because I'm helping myself with the figures. The poles are not shadowing each other. What happens if the poles are interfering each other? I mean, there are two offset wells in this situation, or more than two, in fact. And are they just separated at the time where they are interfering? What happens if they are shadowing each other?
They generally, if they're close distance-wise, then it can be difficult to differentiate between the poles. So it might not be possible to range it.
Okay.
But as long as one well is closer, then it's usually often possible to range it.
And one second question with two aspects. I see that you're putting uncertainties shapes, let's say. First, there is one pole which has a strange shape with two extensions. How is it possible? And how do you compute these uncertainties?
Sorry?
How do you compute the positional uncertainty as we see the shape, the purple shape?
It's based on the it's like a trapezoid, so it's based on the tool face error and the distance error.
But one is not
There's two. Are you talking about the bottom? There's two of them on the left. There's two there.
That's just the label covering it up.
Yeah, it's just how.
Oh, sorry.
It's hard to get a 3D representation on that 2D image.
That's it.
Okay, thank you.
Thank you.
All right, next up, we've got a Jonathan Lightfoot doubleheader. So,
No, it's you first.
Operator Wellbore Survey Group.
I thought I was the second. My bad.
No. Operator Survey Group. Where's that one? Oh, there it is. Yeah, I see it. Give us a wrap. There it goes.
All right, thank you.
You are the first.
Sorry, I was thinking the other presentation was next, but Ali will be here. Won't hear from me twice. I'll be here to answer questions after the next presentation. Yeah, so this is the Operators Wellbore Survey Group. We are a subcommittee officially under ISCWSA. And, this group was started out, Neil Bergstrom was the first chair. And once you volunteer to be the chair, the first thing you start doing is trying to find somebody to replace you as the chair. And then, so Neil went to work for left the operator, so he couldn't be a chair anymore. So that went over to Lisa. And then Lisa was looking for somebody to replace her, but she went to Bessie. So Pete Clark took the job, and I got kind of tired of hearing Pete saying, does anybody want to take the role of chair? So I took it. And he graciously allowed me to take over. So anybody interested in being the chair, I'm more than happy to pass it on. But I love doing this. It's a lot of fun, and I just want to give you an update of what we've been up to as a subcommittee. So we'll kind of go through our mission, a little bit of introduction. I want to read our antitrust statement because it's something that we review at the beginning of every meeting to make sure you understand why we meet as a group. I'll go over some of the recent meetings and the topics that we've talked about this past year and focus areas that I think is important. And then I'll give you an update on RP 78, which was mentioned a few times. So that we'll talk about our mission for this subcommittee is to promote practices that provide confidence that reported wellbore positions are within their stated uncertainty. So that's sort of what we founded it on. That was in 2012. So this is our 10-year anniversary. Really exciting. So I am the chair, and I don't have a vice chair. I don't have a secretary, or there's no treasurer. And this group was really started in Houston. We would meet in person, and it was just, a few of us, and it kind of grew. And then, but here in the last couple of years, since I've been the chair, I decided to let's just do it every other month. So we have 6 meetings a year, and it's just another opportunity for us to collaborate, talk, discuss about, practices and challenges, and look to try to provide guidance back. Now, these meetings were only operators before, but since I've been chairing it, I open it to anybody. So if you go to the ISCWSA website, you can see all the presentations and from the last meetings that we've had. And there's been a few, in addition to the presentation that we run the meeting with, there are some other presentations that are loaded there. Some other items like a spreadsheet that Pete donated and so forth that we talked about at one of the meetings. So we had meetings in January, March, June, August, and September was our last meeting. We will have one more meeting before the year is out. I'm hoping to host that and do that sort of as a potluck right before Thanksgiving. And so I might do that in the Woodlands since it's a lot closer to my home. I don't have to drive to Greenway that day. But anyway, we've been trying to hold the meetings in the morning so that folks internationally can dial in and maybe be a little bit more convenient for them. So it'll be like a breakfast followed by a little potluck luncheon, which means you bring a dish, your favorite dish. I'll make roasted turkey or something for fun. Our antitrust statement is this: we are a meeting to help develop and promote good practices of wellbore surveying, necessary to support wellbore construction, which enhance safety and competition. The meeting will be conducted in compliance with all laws, including antitrust laws, both state and federal. We'll not discuss prices paid to suppliers or charged to customers, nor will we endorse or disparage vendors or goods or services, divide markets, or discuss whom we will not do business with. Nor any other specific commercial terms. These are matters for each company or individual to independently evaluate and determine. And so it's an open door. Anyone that wants to join a meeting, you send me an email. I'll put you on the distribution list. I have to apologize. I tried to extend the recurring meeting, and it accidentally got deleted. So all you got that were part of the deal got a cancellation. Then you got a new meeting, and then I didn't put the right amount of time, so I had to send a third one. So you got 3 emails from me. And again, I'm sorry for that, but there you go. Our meetings have been virtual and Teams. It's the 4th Tuesday of every month, and I appreciate the fact that since I'm the chair, I can move it. If I have a conflict, I'll move it a day forward or backwards, so we haven't stayed with the schedule entirely. Again, it's usually about 2 to 3 hours. Core membership, obviously, is exploration and production operators, from all different, parts of the industry, small, medium, large, independent. We'd like to see more people participate, no membership dues, free to participate, 3 to 4 collaborative discussions or presentations each meeting. And, again, the discussion geared towards our mission and things that we're working on. This is just kind of a highlight of our last meeting, so it gives you an idea. We had 25 total people, 16 operators, and 9 non-op guests that had joined. Had some good discussions, and so just give you an idea of who's participating. Again, I'd like to grow that a bit. The different discussions, we've talked about RP78 and keeping the operators, local survey group members up to speed on that. We had Nikki Robertson from BP gave us a Power BI dashboard presentation. Was really interesting. This past meeting, Chad Hannick talked to us about a generic independent magnetic survey correction, verification, evaluation workflow. That was really interesting. Practicing for everyday purvey, but that should be survey issues. Sorry about that. That was Dallas, and that was my mistake, not his. Drillbotics, and I'll fix that for post this. The Drillbotics introduction, we had Fred give us an update on that, so all the operators that want to contribute can better understand what that's for. We had a IOGP P7 discussion about adopting that P7 17. I talked a little bit about what were quality metrics, the precision placement, value proposition, sensors. We talked a little bit about calibration laboratory standards for magnetometers, accelerometers. Ali actually gave us a presentation on Bezier curves and how that could be used to give you maybe a smoother well path to get back on track or to land a 3-dimensional curve as opposed to the traditional, curve hole curve type deals. And then Pete gave us a couple of presentations on sustained inclination, lateral straightness, and then always review upcoming events, make sure everybody knows about this event that we're having today. Again, our focus areas are operational practice, real-time drilling automation, management of change for safe separation. You'll hear me say safe separation a lot because I don't like the word anti-collision or collision avoidance. I like to call it safe separation because I think it's a better representation of what we're trying to do. We're trying to remain safely separated from other wells. And again, industry collaboration. I do want to reach out to other industries like geothermal drilling and lithium extraction and mining and other groups because operators that bore holes in the earth are way beyond oil and gas these days. So, and trying to have a consistent approach to the local quality related metrics from the trajectory itself. And again, outreach and academic support, student engagement. So those are some of the things that this group's focused on. And so just about RP78, Will Tank has taken over as the chair. He couldn't be here today of the work group. I'm serving as vice chair. Pete, who was the chair before, is still our technical advisor. Ben Coco is still our API sponsor and facilitator. So if you want to get on the work group and you want to have, or your company wants to vote, you need to send an email to Ben Coco, cocob@api.org. And then our technical writer is Evan Bernard. She's about halfway through the rewrite or consolidation of all the different sections, including the 4 revised sections from the QA/QC subcommittee. So we're trying to really ramp this and fast track this and get it across the finish line. So we started in July with the technical work writing. The technical writers, as of last week, is about 50% done. A lot of that was going through all the acronyms and normative references and just trying to really make sure that was reading consistent through the document. Evan, she's in the meat of the document now. We're planning to have an API work group meeting, an open meeting on the 17th of November. At least that's the last time I talked to Ben Coco, and he's working to plan that at an API facility, most likely here in Houston. So you guys that are on the work group will get an email about that. If you're not on the work group, send an email to Ben Coco, say, hey, I want to be on the work group. Our goal is to get a ballot out in December. So we want to really just push this across the finish line. When the balloting goes out, if we have it finally prepped and out, it's going to take 6 weeks for you guys to vote and comment as per API balloting processes. And then we're hoping to get that back, work on the final prep for publication. And I would like to have it published by the ISCWSA drilling conference in March. That's the goal. There's the timeline. And so it's pretty ambitious, but we're just working to get it done. And that's it for me. I'd be happy to answer any questions that you might have. Yes.
Just looking at the balloting time and having read and done this before, have you considered delaying the release per ballot a month? Because having.
During the holidays?
Not
Yeah.
doing it during the holidays, because you may end up with, if you don't end up with enough ballot, like enough responses, it starts the whole thing over again.
Absolutely.
And I do worry, and I think it was just 9 years ago we started this, right?
That's right.
Yeah, and I didn't know if delaying a month might actually help get the sufficient amount of ballot responses, so they don't end up in this weird queue loop, because you ended up just requesting comments during the holidays.
It's a really good point, and definitely we will consider that. That's part of why we're gonna have the group meeting. We may even vote on it in November. We may actually have to push November to December possibly. That's the date we're targeting, but we need to get notification out in enough advance to make sure people can make arrangements to attend. But yeah, I mean, we're trying to really get it, I'd like to get it done before the end of the first quarter next year. It's out, published, ready to go. And then we can write an SPE paper to further deliver that to the industry, and about why that happened. And just so you guys know, the first thing that the operator local survey group started working on was a standard set of error models. Those were funded by Chevron and Conoco. That got put out. That gift of comprehensive set of models was graciously given over to the Aero Model Maintenance Subcommittee, and now that's going to be renamed to be the ISCWSA standard set of models. So we're no longer going to call these the OSWG models. The second biggest thing that we voted on as an operators group was to work on an industry standard, and that's where it all started. Like Lisa said 9 years ago, a lot of folks in here contributed to that. A lot of folks not here also contributed, and the list on the API work group is still about 125, 30 people. So if you change jobs and you were on one of the original section groups that were working on a section of this document, and you have a different email address or different contact information, make sure you get with Ben to make sure you get the notifications. Because we're only going to send it out to the people that are listed on the work group, and each company will have one representative to be a voting.
Yeah, you need to call out that won't respond to, because if you get too many non-participants, it's not valid.
Sure, yeah. API has a formal process for this. Ben's helping us to facilitate that. We're not going to do anything different than their standard process for API standards. So we're going to go all through that the way that they do that on any other standard that they publish. Yes.
Robert Wiley at Central. I'm just wondering where you are with the Dutch to P7 format.
Me or the P7?
No,
yeah, I mean, we discussed it. I'm happy to see that it's getting put into the software system so that we can, if we can't digest it into our software, we can expect people to send it to us that way. So I think, I think it's really important. A lot of work went into that, and I think it's a bit more comprehensive than I ever imagined it would be. But, the folks that put it together tried to think of everything. And, I hope that we can all adopt it, and that just becomes the new way of sending surveys around. And have an import-export feature that doesn't lose and the data is trying to be communicated.
So are you adopting as fast as the regulators are then?
Yes, that's the goal. And if anybody wants to be the next chair, feel free to raise your hand. I'm happy to nominate you. Otherwise, I'll continue to do it. And definitely I'm looking for ideas for topics and discussions. If you have a case study or something interesting you'd like to share, again, we want to scrub it. We don't want to discard any vendors about any things that have happened, but we're just using an opportunity to learn. And the best way to learn is from maybe mistakes that have happened, but we need to make sure that they're clean and cleansed in a way where, you're not actually trying to, rub somebody's nose in a mistake that has happened or something like that. So keep that in mind.
We'll introduce your.
Yes, go ahead.
One more question. I just, not too familiar with the API process. I'm just wondering if there's and kind of follows up on the first question, if there's a representation target that you're looking for small and independent operators across the country.
Yeah, absolutely. Yeah, we'd love to have more small, when you look at the rig count today in U.S. land, it's 70 to 75% private companies, oil and gas companies. The majors and the large publicly traded companies are actually the minority. So we'd love to have more independent, operators there, definitely.
Just to confirm, service providers are being excluded from the code.
No, service providers have a vote, regulators, I don't think have a vote necessarily. It's a choice, yeah. Any independent consultants, anyone can be a part of the work group, but if you have 20 people in your company, you get one vote. So, yes. Yeah, thank you. So I'd like to introduce Alec Karimi. He's one of our data scientists at Oxy, and we've been kind of working together. And I wanted him, I always try to find ways of us sharing things that we're doing, and he's going to talk to you a little bit about this stay in the Polygon lease boundary tool. So there you go.
Thanks, Jonathan. Good afternoon, everyone. My name is Ali Karimi. I'm a senior analytics engineer at Oxy. And the topic for today's presentation is Stay in the Polygon, a real-time lease boundary awareness tool. Before anything else, I'd like to thank Jonathan Lightfoot, co-author of this paper. Without his guidance and help, this work wasn't possible. And also, I'd like to thank Oxy for permission to publish this presentation. Here's the agenda for the presentation. Initially, I'll talk about the introduction and objectives and what encouraged us actually to do this work. Then I'll show you the workflow that we've developed for this tool. I'll talk about the lease boundary and coordinates conversion, which was an important part of the work that we had to do. I'll show you how we calculate distance to the lease, bringing in Python and other tools libraries that it has. And also I'll show you the method that we implemented for calculate distance to the plan. I'm going to show you the validations and also some examples that how we use the tool. We also have the alert setup that I'm going to show you how to set up the alerts. And at the end, we have the summary, conclusions, and a few minutes for a Q&A. Okay, you guys probably know that every year we have a few occurrences of lease violations. It translates into potentially significant fines, loss of production, and so many other legal problems. And it's not because people don't know the lease boundaries are there, they know about it, but sometimes you just get busy with doing so many other things, you're not paying attention to where you're going in terms of drilling, and these things happen. So we wanted this. This was brought up to us by the drilling engineers, and they asked us to develop such a tool that can monitor and possibly give them alerts when they really get close to this dangerous situation. So here are the most important objectives for this tool that we wanted to implement. And so we have to determine if the survey point is inside the lease boundary or outside. If it's inside or outside, what's the distance to the nearest lease boundary? Also, we wanted to use this tool for design purposes as well, not necessarily for real time. So if you want to design a well, it also gives you similar information. It should be able to provide alerts to the drilling team, and especially when you get close to the lease boundaries or you deviate from the plan too much. It should be able to handle exceptions and honor the rules in every business unit, because depending on what state you are, rules might be slightly different. Here's the current workflow that we have. First, we get a list of all the active surveys with available, which have the available surface latitude and longitude. So their surface location should be available. Otherwise, we can't do anything about it. Then we pull the lease boundaries shape files for each well, and that's something that we record in our system, in our database, and we can pull it for every well. The other important part is to get the planned and actual or near real-time surveys to be able to do these calculations, and that's another part of the workflow. After that, we noticed that many times they are in different system of coordinates, and we have to be able to transform every coordinate to every other coordinate for our tool to be able to work. Then we have to determine if the survey point is inside or outside. And for this purpose, we use the power of Python, and the libraries that it has been developed already, ready to use. With a few lines of command, we can do all these. And determine distance to the nearest lease boundary and to the plan. That's the next step. Then when we do all this calculation, we send the results to the database. And then we display the results. For displaying the result, we have a web-based visualization tool that you can have access to it from your phone, from your laptop, as long as you have internet and credentials of the company. So one important part of the workflow was the real-time surveys, and we have service companies that give us surveys, provide surveys, but the problem was we have to be able to get the surveys, well, in near real time. And for that, we make actually API calls to the service company, and they have the surveys stored in their database. We make API calls, we get the surveys, they come in JSON format, and then we convert them to a tabular format that we could use. We do a little bit of data cleaning as well to make sure that there's no outlier in there, there's no crazy numbers. We do a little bit of cleanup. If there's an outlier, we try to usually delete it or use some sort of averaging, make sure nothing crazy is in there. Now I'd like to talk a little bit about lease boundaries and what are the lease boundaries. So the definition is these boundaries are defined as a closed polygons of an arbitrary shape. You guys probably are familiar with it. So they are basically actually like shape files. So most of the time you see simple shapes like rectangles or squares, but a lot of times actually it might not be necessarily like that. It could be polygons. It could be like you have a river on the side. That also possibly a shape file. And a lease boundary. But here I have an example. We have the northing and easting. You see several rectangles here. And the blue one is actually the lease line. And then we have a couple of other boundaries in there as well, which is the green line. We call it 330 by 100, which means that the distance from the actual lease lines, this distance is 330 feet away. And at the beginning, at the end, it is 100 feet away from the lease. And ideally, we would like to stay inside the green one. And that 330 feet usually is for fracking, other purposes, so you make sure you don't get out of the lease. And then you have this red one here for the well, which is 50 left and right, which means that you have to inside for the well itself. It has to ideally stay inside that red box. So so latitude and longitude for the surface locations, they're provided in NAT 27. North American datum 1927, but the state plate coordinates, the way that we recorded, they are in, the lease boundaries that we recorded are in state plane coordinates. So they have a different types of coordinates, and we have to be able to convert one to the other. I don't know if other companies have the same problem, but I noticed a lot of people use NAT 27 for locations and shape files. They're usually in state plate coordinates. So that's why coordinate conversion becomes important, or transformation becomes an important part of the task. I know there is software that could possibly easily do it, but keep in mind that we don't want to call other softwares to do these calculations for us. Ideally, we wanted to have it as a part of the program, and that's why there's a library in Python called PyProj, or Python projection. Very powerful library. You can pretty much convert anything from any system to any other system. But for this, you have to have the EPSG code for that location. And to get that EPSG code, there is another library called state plane. And you can actually give any lat and long to that state plane coordinates. It actually gives you back the EPSG. And we already know the EPSG for NAT 27, which is 4267. Now you have both EPSGs, and now you can convert pretty much or transform any coordinates to each other. Here is an example in West Texas. And you see the lat and long here, or long and lat here. First, we get the EPSG, and then we call pretty much this transformer method to build that conversion, and then we just call the transform method to do the conversion. And that's how you get it in state plane coordinates. And these are the numbers from the previous slide. It looks much closer to these numbers, right? So that's how we do the conversions, and you can do it conversion in batch, so it's very fast. If you have like 20 wells, 30 wells, it's very fast. No problem in terms of speed. Now we get to other fun part of the work, which is another library called Shapely library. And this one, we use it to determine if the point is inside or outside of a polygon of an arbitrary shape. For a square or rectangle, it's pretty easy. You don't need an algorithm for that. But when the shape becomes complicated, then it's not that easy to do the calculations. But for validation, I'm showing an example here for you guys to get a feel of what we're doing. So I'm defining a polygon here of this shape, right? So this is the polygon, and this is how you define it. We have 4 points, 4 corners, right? But keep in mind that the first point is repeated, and that's how the shape files are. 0 and 0, and 0 and 0 here are repeated, which means that it's a closed shape. When we build this polygon, then we can make any points, let's say 40, 20. Here is 40, 20, right? And we just call this method within, and it returns true or false. If it's inside, it's true. If it's outside, it's false. And then we use the other method, like exterior distance, to actually gives you the actual distance to the nearest boundary. In this case, it's 20 feet, and you can see it from here because it's 20 feet, 20 and 40, right? It's 20 feet to this boundary here. But there, if you go to this point, 120 and 120, it's outside of this polygon, and that's why it returns false. And the distance is 20 times the square root of 2, which is about 28 feet, and gives you exactly that number. So pretty reliable, interesting library. It was just part of the capabilities they had. But for validation, we also have other methods publicly available, very well-known, famous Google Maps. You can use that as well. And here we have a surface location, and you can just draw a circle around the surface location to this orange line, which is the boundary. And that's something that we show on the tool. So if you do that circle, the radius of that circle is around 131 feet. And our tool also shows pretty much the same number. So having these validations, it just gave us confidence to go ahead with the implementation and actually use it. And I'm going to show you some results now. But before that, I'm going to use some terminology that you guys probably are familiar with, but for those of you who are not, these are some definitions that I'm going to use. And probably when I show you the results, you might ask me, what are these points? So I'm going to explain what they are. So we have the surface hole location, SHL, pretty obvious penetration point, or PP, location at which the upper formation is planned to be penetrated with respect to a given rule. Then we have the first take point, the first point that you can legally penetrate and get oil from. And last take point, same thing, last point that you could get oil from. And then we have the EOT, which is end of the terminus. And you cannot, the total depth cannot exceed this point. And this point still should be inside the lease boundary. So these are some of the definitions that we use for Texas. For other states might be slightly different, but that's a different story. Okay, so here, let's talk about the results a little bit, how the results look like. So on the x-axis, we have the measured depths. Might be a little bit difficult to see, but on the x-axis, we have the measured depths, and the y-axis, we have distance to the lease. So we have several lines here, a horizontal line, we have the 0 line, and we have the 100 line, 100 feet line. And the reason that we have 100 feet line is usually you don't want to get closer to 100 feet. It's for easier visualization, basically. In terms of solid lines, the solid line here is the is the planned, and the dashed yellow line is the actual. So, which basically this graph shows you that at measured depths of 0 at surface, you're around 120 feet away from the lease boundary, right? And if I zoom in here, probably easier to see. So this is your surface location. Then you get out of the lease, and you can actually do that usually before penetration point. Really depends on the state rules, but that's quite common before penetration. You can go outside of the boundary and then come back in. But usually your first take point, must be inside the lease, inside the black lease actually, which is 330 by 100. And that's why it shows you a negative value. That's how we determine if it's outside for easier visualization and display. That's why these numbers become negative here. And when you go back inside again, then it becomes positive. You don't have to worry about it at all. at this point because it's just very far from the lease lines, and at the end, it drops back down. When you get close to the end, it drops back down to almost very close to zero. So this is how we represent the results, and you see all the boundary lines that I mentioned. This is the release line, 330 by 100, and this is 50 left and right. And you see all those points as well, the first point, last point, first take point, last take point, etc. Here's another example. I thought this example was interesting because when I was doing this work, it was pretty interesting to me. The surface location, you could be outside of the lease boundary. But again, first take point should be inside the lease. And that's why similarly here, you see that you are around 500 feet outside. When you start the well, you go all the way down, but after you build the curve and then you want to land the well, then you go inside the lease. Just another example, the other thing is we show both planned and actual. So as you can see here, we are at this point and then we are following the plan pretty good. We're staying inside this 50 left and right. So one other thing that we wanted to show was distance to plan. Because you have your plan, and ideally you don't want to get away from the plan too much. Sometimes you can't help it; it might be a few feet, but ideally you don't want to get too far from the plan. And in order to do that, we use a method called the discrete boundary model, and it is a general model to calculate the shortest distance between any two objects. So not necessarily a well, but basically any two objects, and that's very general approach. Just imagine you have two objects. The way that you do it, you put meshes on both objects, and if, let's say, for example, we calculate the distance from this mesh to all the other meshes, and you do that for all the meshes. You pick the shortest pair, or the pair that gives you the shortest distance, and that's the nearest distance between two objects. And that's the method that we use to determine the distance to the plan. We initially developed this for, or Jonathan said, safe separation tool, but the same method could be applied here. The only difference is that you have the reference well and your offset well. This time is your actual well. And let's say this is your survey station. Then you divide it into different nodes or meshes. And you calculate the distance from this location to all these other nodes and pick the smallest one as the nearest distance to the plan. And it's similar to the growing sphere method that people are familiar with in this specific case. But yeah, we also do the calculations for the distance to the plan as well, because sometimes lease information might not be readily available, or there might be some other issues with the data quality. But even having distance to plan, if your plan is correct, it gives you some additional check to make sure that you're not getting too far from the plan. And here we have an example of that. Again, the x-axis is the measured depth, and the y-axis is distance to plan. Well, initially, we assume that we kind of ignore the surface location uncertainty because for simplicity, and that's why they're exactly starting at the same location. But you see that it's like 10 feet off, around 8,000 feet. And then usually something that I saw that during the building the curve, usually the distance becomes more. And that's something that you can actually see here as well. The solid line is the plan and the dots are the actual. So this graph exactly kind of confirms what you see on the map as well. And ideally, we wanted to stay inside this box. You see that they are slowly going inside the box, and that's why there's this 50 line here, and they stay inside the box for most of the well, but they get outside for a little bit, they come back in again. This was a kind of a rare example. Most of the time when they land the well, they stay inside the box. So we have all these, but you're not going to monitor it 24/7. Nobody wants to do that. And that's why we have this alert system. So for all the active wells that we have, you can go over here and actually kind of create your alerts. So you have the well API number, and you have the send alert. It could be like yes or no. If you don't want to send alerts, you just say no. We can put emails here, any email that you want. Some engineers asked us, since they have a Teams channel for their rig, they wanted the email to be sent directly to the Teams channel, and that's something that can be done as well easily. Then we have two triggers, distance to the lease and distance to the plant. In this example here, we say that 50, which means that if you get closer than 50 feet to the lease line, it's going to send you an email alert. And same thing for the plan. If you get 80 feet away from the plan, it's going to send you an email. So that's how you work. You work with the alerts. We run the tool right now, usually every half an hour. So it's updated very quite often. Okay, summary and conclusions. So we developed a real-time tool to monitor distance to the lease boundaries and also the planned wells. We get the real-time surveys or near real-time surveys by making API calls. We use Python libraries, pre-existing Python libraries, to speed up the work and helped us a lot to shorten the duration of the project. We implemented the discrete boundary model to obtain the distance to the plan. There's customized alerts for every well. You can have a customized alert that was set up. The tool was tested for several wells and successfully provided warnings. And actually, when it sends you an email, it has a sort of automated narration that fills out all the numbers, like you're this much from this well, and the numbers actually go inside the alert with the image of the of what the example that I showed you. And we think that it could significantly reduce the lease violation incidents that we have, and if you guys want to implement it, possibly in the industry as well. At this point, I'd like to again thank Oxy for permission to publish this presentation. And even though that I'm presenting today, but there are a lot of other people involved, and without their help and support, this work wasn't possible. And that's pretty much it. Thank you very much for your attention. I'll be happy to answer questions. We have a few minutes, I guess. Yes.
Consulting Dushan and WSP, thank you for the presentation. I think great. My question is, do you consider EOU, electrical consultancy, for the purpose?
Looks of uncertainty for the lease boundaries or for this or center to center?
For lease boundaries.
For lease boundaries, no. Okay. No, but that we have that 330 by 100 line, so that kind of should take care of most of these. I think these GPS locations are pretty accurate. You know.
VP. I'm kind of curious how the alerts are. I understand how they're working. We've got something very similar, and we get alerts, and we've had to tone down the recipients because everyone thinks at the beginning you want to be notified when something happens, and then it continues to notify you that you're in this area that's okay, but you don't necessarily want to be there, and so eventually we turned it off except for very exclusive users because we were afraid we were getting alert desensitization. I'm just kind of curious what your guys' experience was.
That's a very good question because you have the same issues, and there are two ways to do that. First one is if you go back here, turning off the alert is very easy. You just go over there, send alerts, no, so it's not going to send anymore. The second way that I added was it only sends you alert when you're doing active drilling because we get 1 second with SML data for these wells as well, so we know if you're drilling or not. And also, for some reason, if your with SML is not updating, the surveys that are coming, it compares the current survey with the previous survey, and depth has to be increasing. So, for example, you're doing casing, you're not doing anything, right? Before you're really close to the lease boundary, it's not going to send you a bunch of alerts. The next time you start drilling, it's going to send you alerts. That's how we took care of it.
Well, it's drilling. I've got two questions, which maybe a little awkward at times. First of all, why do you think you had to go about building a new tool when there are tools available on the market that are doing this already? With more stuff involved as well in terms of looking at coordinate systems, all the rest of it, you're already engaged in doing it. Secondly, one of your slides is using Google Maps or something
Yep.
to verify the tool position.
Mhm.
Have you ever looked at the Google Map position of the zero meridian that goes through the ditch or cemetery? It's about 100 feet off from Google Maps.
It could be,
So,
yeah.
so Google
But
Maps
it
is
depends
not
on-
really a good reference when you're looking at tool accuracy. You might want to ask Jonathan to see if you can take the introduction to wellbore positioning course. Just a sales pitch. But I'm also interested in why you had to go back and, think you had to put in a new tool when they're,
Yeah. So to answer the first question, you can go.
Well, yeah, I mean, it's a good point. We do recognize that that's ISCWSA is forward. There's a lot of issues with Google Maps. We do have, Digital Globe and CardinalSnap maps, and we have a different mapping system that we use for positioning. I think the question that Constantine had was misunderstood a bit. We weren't talking about, he was talking about the subsurface EOU, not the surface location. That's where you mentioned the GPS. We do a lot to do a surface location verification with the geomatics team, but this is not a primary system. We still have our directional software. We still have our vendors doing the work. This is a secondary system that provides another layer of visualization of this. But, when you look at the actual corners of the lease boundary, the well planner has to get that from a certified registered land professional and get the points really mapped out, not just the lease boundary, but also the individual field rules, meaning basically the buffers that have to be set up. That has to be entered. That does go into the directional drilling software, and a well planner can load that into the software and run proximity against those boundaries in the commercial software. This is just another tool to pull that out of the database that's been loaded by a seasoned well planner to provide additional visualization. That's really the intent of this is additional alerts, but we're not using Google Maps for anything.
Yeah, there's a Google Maps. I'm glad to hear about that. I thought it was just a validation of this. But I'm also saying there are other tools out in the market that are doing real-time visualization, 3D visualization of this stuff with direction, with alerts and possibilities to different lease lines in different places. And this seems a big effort to go through developing a tool that's already available.
Good point. Well planner, we've seen, some issues, various vendors put in the lease boundary, but we're not sure where they're really getting that from. So we've taken that internally. We have our well planners in-house, digitize those points, load them with with direct correspondence with our land survey company. So we're trying to just have an additional bit of, guidance to make sure that we don't drill outside of the trespass. That's really what the whole point of this is. And down the road, could we incorporate position uncertainty? That would be a further step. This is very new. This is just the first step in many to come as we get more advanced in data analytics.
Phil Scott, Dynamic Graphics. Is Tim still in here, by any chance, with the road commission? Is he already late? So, okay, and this might be a good question to ask you too. About 12 or 14 years ago, we had a meeting with the road commission at a few of the service companies. And the road commission made clear that the hard lines are based off of the perpendicular motion of the tool, right, and not necessarily the lease line, due to like the fracking parameters of the well path. And so it's going to say moving forward, it might be worthwhile taking into consideration that you're not necessarily looking for 330 foot from the lease line as being your hard line, but 330 foot from the well path, which if you're at an angle isn't necessarily 330 foot from the lease line. So as you move forward, as you evolve, there might be something.
Absolutely, that was also brought up by our building engineers as well. That's something that we're going to add to that perpendicular line to the lease line. Yeah. That's a very good point.
I can also attest to that. They had the court case that went to the Supreme Court in Pennsylvania, where there was a wellbore that went adjacent to somebody's land, where in here we could argue about it all day, but essentially the well path was within, let's say 15 feet of a corner of somebody's property, right? So it stayed within the lease. Now it was in Pennsylvania, so they didn't have the 330 foot off offset. But then once they fracked it, right, obviously it went further than 15 feet. So then the court actually ruled in favor of the operator and said that it was not trespassing. So I don't know how many people know about that case, but it was something that I was glued to, so don't really know why. But we're, okay, so that's, Todd, so sorry, but I mean, we've got a break, but you guys can.
Okay, yeah,
talk
I'll
in
be
the
around
hallway,
if you have any
and if everybody just wants to listen into the conversation, follow the deal. K&M has once again provided us with food, thank you so much. There's stuff at the back, I think there's granola bars and stuff like that, so feel free to just dump them all in the bag as towards the end of the day.
Thank you, Ollie.
Back at food.
I need to make a quick change to my front cover.
No.
I've used that before, but
We gotta like close out all of these. So wait, which one's up next? Oh wait, no, that's not subcommittee.
Yeah.
I'll use it.
I put my acknowledgements at the end, where everybody else has mentioned co-authors.
Okay.
So it's just,
Yeah. I'll be right back. Yes, I say.
Thank you.
final home stretch of the day. There are still good presentations, so please find your seats. I can't say that we saved the best for last. I don't know. We haven't seen them yet, so hopefully. We need you to unlock it. We will start without you. The presentations can start without y'all paying attention.
You have to speak out.
Hey, sit down. I was trying to be nice.
How do I activate the pointer? Do you just... Oh, yeah. Oh, yeah.
There's that one, and then there's also that one. So.
All right, thank you.
All right, we're going to turn it over to Barry. Barry is going to be talking to us about solid state gyro technology, allows safe and reliable real-time remote operations. That means stop talking.
Hello, good afternoon, everybody. My name is Barry Smart from Gyro Data. I've been with Gyro Data for 24 years, started working with them in the field, and progressed into operations support and then a technical support role, which I've been doing since 2007. My presentation today is called Solid State Gyro Technology Allows Safe and Reliable Real-Time Remote Operations. It's based on SPE 205870, which was written by Adrian Ledrose, myself, and Navin Maharaj from Halliburton. So the content, we're going to go over a very brief background on gyro technology, and then go through a tool verification process and how that relates to remote operations, and then how we progressed into uncrewed operations and fully remote operations, and really how we can use increased automation in the future. And we'll finish off with a look at a couple of case studies before reaching conclusions. Okay, the background of gyro sensors, for the purpose of this, we can split it into two categories where we've got post-drilling surveys, where the gyro is not part of the BHA. Initially, the first gyro tools were run on wireline. We could run either multi-shots in casing, tubing, or drill pipe, or also for single shot or orientation purposes. The drawback the benefit of wireline was that we had real-time communication. We could talk to the tool, switch modes. Also, when we developed continuous mode, we could transmit high-resolution data real-time. The drawback is obviously you need a wireline unit, you need wireline operators, so there's quite an impact on rig operations, and also it can be time consuming. When we use it for single shot or orientation purposes, it becomes even more time consuming. When drilling became more complex in the 80s, we ended up with occasions where we needed to run in excess of 50 wireline runs during a survey campaign. This could take up to two days of rig time. The next development was the memory drop, which we run in drop or slickline mode. The drop tool enabled us to remove the wireline from the rig for multi-shots, but it still didn't resolve the issue with kickoff campaigns and single shots. In the early 2000s, this was resolved where we had real-time drilling surveys. The gyro was part of the BHA, where it could be run in either motor or RSS assemblies. With a motor assembly, the gyro would be used for real-time surveys, but also for the purposes of kicking off the well. With RSS assemblies, the gyro could be run nearer the bit because it wasn't subject to magnetic interference. It could also provide independent survey data and a reduction in uncertainty with reduced EOUs. Typically, when we run these tools, we run them with the MWD as the host. So the MWD would send us pumps off commands to initiate a survey cycle. We would then send the survey data back to the MWD tool, and it would transmit it to surface. When the first gyro well drilling tools were developed in the early 2000s, at the start of the millennium, they were all based on spinning mass gyros. The example here we have is a dry tune gyroscope. The bottom half of the sensor has a spin motor and bearing assembly. The spin motor spins at many thousands of RPMs typically, and the bearing assembly will support the rotor. It needs to be well maintained and lubricated so that the tool can operate from its range of very low temperatures near freezing to in excess of 100 degrees C. If we look at the image on the right, we can see how the gyro can work as a north-seeking tool. We have these flexible couplings, a flexible coupling which allows the sensor to move freely when it's subject to the Earth's rate of rotation. This movement's offset by torquer coils, which stabilizes the sensor. So the gyro is subject to very low noise. However, it's fragile. Rated at 8 Gs RMS for vibration. When we compare that to 20 G RMS for an MWD tool, it typically is the weak link in the BHA. In addition, the flexible couplings that allow the sensor freedom of movement are subject to bending, which can result in movement and calibration, or even braking, which is terminal for the gyro. The tool itself is very complex. Typical examples are around 16 feet long. It has high power consumption, typically around 30 watts. This power consumption can also vary because if the tool is moving during data collection, the torquer coils have to work harder to maintain the stability of the sensor. Also, the tool requires spin-up time, approximately 30 seconds. The next generation of gyroscopes, which were running gyro well drilling mode from 2020, were the solid-state gyroscopes. The example here is a sort of tuning fork design, but you do get different configurations. This is much simpler in operation than the spinning mass tool. We can see here that the sensor is vibrated in a drive motion. However, when it's subject to rotation, it sees motion at an angle other than the drive motion, which causes a change in the nature of the oscillation. And we can measure this in order to establish azimuth. So when we compare it to the dry tune gyroscope, the solid state gyroscope has low noise, slightly higher than the dry tune gyroscope, but this isn't really significant in terms of the IPM or error model, because environmental noise is the dominant term there. It's more robust with the equivalent rating as an MWD tool at 20 Gs RMS. The tool's simple and shorter, 3 feet long, which means it can fit in a much shorter collar. And also it's got very low power consumption, around 2 to 3 watts. There's no spin-up time required for this, so it can operate within 1 second of starting up. In terms of remote operations, the fact that the tool is robust, short, and has very low power consumption leads itself to in-collar loadouts. In order to evaluate if remote monitoring is feasible and plausible, we need to look at the tool verification process. This is probably similar to most other measurement instruments that are run downhole, where we have a cycle where we start with a job call-out, planning and preparation phase, where we gather information required to mobilize the tools and assign appropriate tools and people. We then go on to pre-job activities base, where we'll do standalone system testing and also combined system testing with the MWD tools and other VHA components. We then move on to the rig site, where again, we'll function test the systems and double check all of the critical information. We then go on to job execution downhole. As I mentioned previously, the data is typically transmitted with the MWD through the MWD system and pumped up to surface from there, at which point our survey specialist will decode and QC the surveys. Post-job activities well site can include additional testing, and then back at base, we verify all of the testing completed, do additional testing, and put the tool into its next phase, which is maintenance and recertification. The 3 phases highlighted are the ones critical to remote operations. So we look at the dry tune gyroscope against the solid state. We can see that the job phases have quite similar timings in most cases. However, the pre-job activities well site is abbreviated considerably. The dry tune gyroscope needs full system testing offshore prior to building it, loading it in the collar, and testing it with MWD. The solid state tool doesn't require the same extent of testing and can be configured and loaded into the collar straight away. Similarly, post-job, we don't need to complete calibration verification checks at the rig, so the tool can just be basically disassembled for shipping back to town. It's also worth noting at this phase that during job execution, the survey time is reduced due to the lack of requirement for the tool to spin up and stabilize. So you're looking at reducing the survey time from 2 minutes 20 to 3 minutes 30 seconds down to 2 minutes. Also, the equipment maintenance and recertification phase is reduced considerably, because typically we don't need to recalibrate the solid state sensors. As mentioned previously, the characteristics of the solid state gyro lend themselves to in-collar loadouts. That can create further efficiencies where we can push some of the activities completed at the well site to base, either pre-job or post-job. This leads us to the process of implementing remote operations. So with the dry tune gyroscope, we have 2 service specialists at the well site. The tools are loaded in the collar at the well site, and the pre-job well site checks are completed by the service specialist. The job execution phase is also completed by the service specialist at the well site, and he'll decode and QC surveys as required. The first phase of heading towards remote operations is to remove one of the service specialists at the well site. The tools are still loaded in the collar, and the pre-job well site checks also completed by the service specialist. The job execution phase is completed by a combination of the service specialist at the well site and the remote monitoring center. What this phase does is basically confirm that we can carry out the job execution phase remotely. When we did this, we largely used third-party software to to send survey data to town and decode it. And we also completed, we had a workflow with basically a process where we had different phases where ideally we would use the third-party software to decode the surveys. If that wasn't available, we would then go to a method of screen sharing, and then the last resort, the third phase, was communication by telephone. The next phase, phase 2 of solid state, was to have 0 service specialists at the well site. The tools would now be loaded in the collar at the base. Pre-job well site checks are completed by the MWD operator, and they're checked by the remote monitoring center. And job execution completed by the remote monitoring center. This phase had a number of challenges. Primarily, when we load the tools in the base and we don't send any service specialists offshore, we're removing the safety net of being able to reprogram tools or reconfigure tools. So some of the checks that were finally completed at the well site previously had to be completed at the base, which meant basically developing new procedures, also RASCI charts to make sure that people were aware of their responsibilities and roles. The final phase of the uncrewed process, which we are in the process of implementing now, is where we have no service specialists at the well site. The tools are loaded in the collar at the base as before, but now the pre-job well site checks will be completed by the MWD operator alone, and job execution completed by the MWD operator alone. This would allow us to create greater efficiency. We would be in a position where we could simply deliver a collar to an MWD operator and then receive the collar back at the end of the job. In order to implement this and to avoid extensive training of third parties, we're testing and trialing a method of automation for the survey process. The surveys are auto-decoded by software at the well site. The software taps into the MWD feed and also the ISCWSA feed. So we can QC the survey and give instruction as to what to do next. So a good survey would typically, would result in an instruction to drill ahead. The interrogation of the additional data in the WITSML feed also allows basic troubleshooting to be completed and generate recommended actions for surveys that fail QC. So we have a survey that fails QC, the instruction is to resurvey, and then the resurvey instruction tells us what the issue was. In this case, I'm not sure if you can read it very well, but in this case, flow was detected. The standpipe pressure changed while we were collecting survey data, and the recommendation is to talk to the driller and basically retake the survey. This process, by automating this process, it also speeds up the troubleshooting process, as it can be done more quickly and automated than by a survey specialist in a remote monitoring center checking drilling parameters. The automation can also be used not only for QCing and decoding surveys, but for highlighting and setting off alarms for out-of-spec conditions like shock and vibration, flow rates exceeded, etc. So I've got two case studies to show you. The first is from a jack-up with 16-hole section with phase 2 uncrewed operations in the North Sea Norwegian sector. We experienced magnetic interference between 550 to 850 meters, which is not shown on the plot. And then typically, once clear of magnetic interference, we would potentially switch over to magnetic surveys. However, in this case, because of the ellipses of uncertainty related with a basic MWD model compared to a multi-station corrected model, the MWD would have required a rotation shock to drill ahead. Instead of doing this and wasting about half an hour rig time, they simply built the PD using the gyro well drilling surveys the whole way. As you can see, the gyro well drilling and fully corrected MWD surveys had similar ellipses of uncertainty. So there we saw the benefits of seamless drilling in an area of magnetic interference and a rig time saving of around 30 minutes. This gave us independent validation of the MWD data. The next case study is from a jack-up 12.25-inch section. Again, phase 2 uncrewed operations in the North Sea UK sector. We had no expected magnetic interference in this section, inclination 68 to 71 degrees. Again, as you can see, the corrected MWD and solid state gyro well drilling surveys gave similar ellipses of uncertainty. Unfortunately, in this case, neither was sufficient to hit the target at the end of this long section. So in order to complete this over the 18,000-foot section, the directional company combined the MWD and solid state GWD surveys to produce a reduced ellipse of uncertainty, making hitting the geological target achievable. So to summarize the uncrewed operations, we've got a number of environmental benefits that go beyond the obvious saving personnel offshore and helicopter seats. We've also got lower battery consumption. The reduced battery consumption means reduced environmental impact, and it enables remote operations where we can ship a tool in standby mode and still have plenty battery power to drill extended sections. We've got reduced and lighter shipments, smaller shipping boxes. If the tool's loaded out in collar, we're not sending a container to the rig site as well as a collar. And we've got a shortened collar requirement. We also have fewer shipments where maintenance frequency is reduced and calibration frequency is reduced. Less engineer travel, domestic and international flights. And then finally, for the rig impact, we've got fewer crane operations, a reduced footprint on the rig with no container, and reduced PHA handling. So to conclude, the solid state technology contains a number of benefits over spinning mass to enable remote monitoring, lower power consumption, increased shock tolerance, no shift in calibration, and no requirement for real-time or post-run corrections. We've got simplified testing in QC, and then high levels of automation are also achievable, allowing tools to be run by third party with minimum training requirements. Okay, thank you. Any questions?
Okay. Thank you so much. Hi, I'm Lisa. Lisa, wow, bad influence here. But thank you so much. I think this is really great. I think that I can see that the human factor can really be taken out of some of that. So this is good. They did have a question about how the accuracy compares to the spinning mass gyro versus the solid state. So I can definitely see the benefits, but I'm just curious from she didn't.
Okay, the solid state gyro is more accurate than the spinning mass because we've basically removed the mass unbalance term, which is a significant factor in the spinning mass gyros. So we have considerably smaller ellipses of uncertainty with the solid state.
So do you see these replacing the entire gyro fleet?
Yes.
Jerry Codling, Halliburton. One of the issues I see with a combined gyro and MWD over a particular hull section is actually a data management issue.
Yeah.
It's like you get mixed gyros mixed up, and then they change the survey tool and things like that, and all of a sudden you get reduced EOU. My preference, and I'm looking for suggestions, is actually just to have a hybrid error model, which is almost like MWD verified by gyro or gyro altogether. I mean, your ellipses were looking pretty similar. Yeah, so any suggestions?
Yeah, we do have it, and there is an operator in Norway who also has a similar methodology where the MWD model is significantly larger, and when it's verified by a gyro, the ellipses are shrunk considerably now. But yeah, there are a number of different ways to implement that, but for sure, if you're combining different surveys, the management of IPMs and databases is a consideration.
I'd like it to be entered all as one run and be described as a mix and know which stations came from which.
Thank you for that, Robert Estes and Halliburton. What's the maximum operating temperature for your solid state gyros?
You're looking at around 140 degrees. We're limited by basically calibration range. So as high as we can calibrate it, we can operate. So 140 to 145 degrees C.
We have ovens that go higher than that, which can help you out. But the device itself, in the future, what do you see as the ultimate limitation of the maximum operating temperature?
Oh, you're going to take it.
Yeah, so the sensing element can go higher, but we need to work on qualify all the electronics, the memory and all that to get something that we have not done. But yeah, the sensor can go higher than the one.
You see this as a potential geothermal navigation tool?
Possibly, but yeah, so far also the market for that hasn't been that much, so we are focusing on the main market.
Thank you.
All right, thank you for the presentation. All right, next up, we've got the Survey QA/QC subcommittee update. And take it away.
Thanks, David. So, yeah, this is the Survey QA/QC activity report. Typically, it'd be delivered by Phil, but as we talked about during the webmaster presentation, he's unable to make it. So, he was missed during this meeting, but I took the reins very willingly in the last couple of weeks here and tried to gather the troops. So for those who don't know me already, my name is Mike Ashel with Pacer Directional. I've been involved with the ISCWSA for the better part of 10 years, while being involved in directional drilling operations and planning. I've also been a part of the DSAT's robotics competition, which was discussed already earlier today, and also the Canadian Well Acquisition Committee, which is kind of like the Canadian version of the ISCWSA, just to disseminate the same information we're talking about here. So the QA/QC subcommittee is a fairly new committee, well, I guess the newest one in the group. The way I say it, this isn't like an official Venn diagram, but basically it kind of marries the air model and education subcommittees and puts that effort into putting together some recommended practices and talking about how to best implement QCing of directional survey data. So during our meeting, we had a fairly concise but determined agenda of getting a status update on the documents related to the RP78, which was gone over earlier today by Jonathan. So there were originally 4 documents, and they were quite long, a lot longer than the API was allowing us to submit to them. So they were chopped down to about 4 pages each for the API submission. And the intent during the meeting and just as a subcommittee as a whole was to turn those original longer documents into ebook content similar to the Intercept and the Over Positioning ebooks. So yeah, we went over each document and got a status update. I kind of booked 20 minutes to go over the status updates. They're very quick, 30-second no progress updates from all the different groups. So we kind of moved on to the next section of the meeting and talked about where we wanted to go from there as far as the ebook getting prepared and how to handle each document. One of the things that wasn't brought up when the ebook initiative was first started was an MSA correction recommended practice. So that was quickly pointed out as a missing aspect from the original 4 documents. So we had a presentation from Chad on his correction method or correction validation method proposed with the synthetic survey data. That was just motivated by basically having questions from operators and service providers of how corrections are being done, why when you send the same survey to different providers, you get different answers, and you just want some sort of additional method to validate a correction method, to at least start the conversation. So during this presentation, he went over the method. I'm not going to go into that here. It's kind of its own thing, and if you have any questions about that or are interested, I recommend contacting Chad about that. And I'm sure he'll give a presentation to the subcommittee as a whole. So basically, there's a very, very enthusiastic conversation, to say the least, about the method being proposed. But long story short, it was kind of established that we didn't want to at this time anyway, promote the validation tool as, any sort of gold standard or definitive confirmation of a correction method, but it could be a very useful tool, both for operators and service providers to run against a correction method and kind of have a jumping off point of further conversation from there. So the next part after following that presentation, we regrouped into the aforementioned document editing groups. So we have the MWD and the members listed on here, just the present members, not including any of the members not present or who might want to still be involved. So the MWD had 6 members with Chad as the lead. The Gyro had 3 between Ben as the lead, and then directional survey directors. I put Mike Long on here. He's not here, so you can't really complain about that, but he didn't really volunteer for that, but he was kind of leading that in the past, so I just put him on there. So if you want to get involved in, and you can email me too, or Bill. And then depth, Harold wasn't around, but he's kind of put together the document as it currently is, and is pretty much all ready to go. So there really isn't any editing that needs to be done for that one, but he's leading that effort. And the MSA recommended practice ebook content would be a TBD item right now, and Chad is kind of told to be the lead for that, but that's still to kind of be confirmed as far as who's officially leading that effort. So this is a bit of a high-level view of the subcommittee's activities at this point. So as far as the ebook itself goes, the depth, like I said, is basically done already. Still to be peer-reviewed and officially done, but I think in a previous subcommittee meeting, we had accepted that as ebook content that was ready. The other 4, between Gyro and the API, minimum requirements, and then directional survey records, those are all kind of concurrent things being worked on between the different groups that are identified. The MSA one, like I said, is to be assembled still and worked on. And then we just added on the survey QC testing for Chad's proposed method. And then another one that Annie had proposed on the air model maintenance side, asked us to look at some field acceptance criteria that was tied to the air model tolerances and assumptions, kind of related to the qualifier question from before, to come up with a better field acceptance criteria that was closely aligned with the air model assumptions. Phil wanted me to plug this. It's a kind of a joint effort subcommittee between a couple of different SB groups. So the Joint Data Quality and Uncertainty Description, DDCUD, I think is what they called it. Not quite on board with me, but that's what it is right now. So it's led by Phil and Eric Caillou. So he was involved quite heavily in the robotics the past couple of years. So I've worked with him on that side, and he's a really knowledgeable and good wealth of information for that. So this subcommittee is between the DSATs, the UPTS, and the WPTS. So the drilling systems automation, the drilling uncertainty prediction, and the well positioning, of course, through us. And their activity has been involved in basically just validating drilling data, kind of giving recommended practices similar to the survey QA/QC, but more specific to drilling data as a whole. And they've got a couple of different reference materials that they've put together and initiatives that they got going on. So they put together a paper just kind of introducing the concept of the drilling data uncertainty, just to bring attention to it to the industry. So that's about it. So thanks to everyone for showing up. We had, like I said, 18 people show up, which is about 15 more than I expected to come. So I appreciate everyone coming out and showing that interest and being willing to be a part of the efforts of editing these documents. Action items going forward is obviously just to kind of keep going forward with editing those documents and reaching out to anyone else who might be interested. So if anyone here does want to get involved in editing those documents and being part of the ebook effort, then get in touch with myself or any of the others that were listed on there, and we'll make sure that happens. Thanks. Any questions? Well, you guys are going easy on me. Appreciate it.
All right, thank you, sir. Next up, we've got Benny with the, I don't know, one of the committees.
ISCWSA
Here, hold this while I do the mic, this thing. There it is.
Jamie, where are you, Jamie? Ah, you're in the back. You should go in the front, man. They squeeze me around here. You need to protect me.
Oh, let me guess, you're one.
Yes, that's correct.
Whisk.
One.
Whisk.
It's easy. It's one.
It says WISC. It says whisk.
Yeah. Well, intercept subcommittee. Okay, that's good. Thank you, thank you. Just want to provide the updates. I think I already gave some feedback on the distinguished lecture, and the members tell me, and Jamie, and I have a team here in this room. They've been working hard to put the ebook together. And our mission, I just want to reiterate, we want to share the knowledge, right? So one of the things that we've been able to achieve is through the ebook, right? Ebook is one of the most downloaded documents, and it's been used as well by the university student chapters, by the operator and the service company. So we have the slide here about the distinguished lecture. I will skip it. And let's look at the revision 4. First, the question I asked with the teams is, do we need an update? Okay, because the last version was launched in 2021. Okay, as a consensus, as a group, we said that yes, we need update. And resources, we have a SME and technical writer. We're missing technical writer, and we said that yes, we need that. And the next question I asked is, how about the funding, right? If there is no funding, it's very difficult to move. Okay? So we as a group decided that we're going to write a proposal. We'll submit it to ISCWSA, you guys, Adrian, your teams, and maybe we have to find some creative way. Maybe we find a sponsorship to be allowed to do that, okay? Just like a YouTube channel, right? If you watch it, you have advertisement, okay? So the same thing with the ebook. When you download it, you put advertisement. Just kidding. So that's the that's what we're thinking to move forward. So what works need to be done? We need to address the version 3 feedback. There is a lot of the detail that we need to address, like the graphic qualities, some text required clarity of the text. As a new section is a surface location as an appendix. That need to be put in there. And then acoustic ranging with the latest processing. And then the fourth one is a passive magnetic ranging using a 3D distribution technique. I think that probably is a worldwide as well for industry to at least to know what is the latest development in passive magnetic ranging. And then the next one is the question is right now the well intercept. We have to expand not only oil and gas and also to the geothermal, which is an advanced geothermal system. I think that's probably in line with what we're trying to do. So I would recommend maybe we should consider changing the name, ISCWSA to something else, okay? So that's what I think as a group probably we need to do that. And so the logos need to be changed to some of the image, okay? To make it more attractive. I mean, that logo is 1970, 1980. Okay, just want to put the team member here that will plan that's going to work on revision 4. We have a couple of chapters that almost done, but need to be cleaned up, need to be reviewed with the technical writer. So that's the current status, and we're going to add as well with the, as I said, move to the geothermal, advanced geothermal system. That's where the interception will be required. Okay, and we've got a lot of requests from the geothermal community or the new startup, how we do the stuff, what we can do in the what they can use from the oil and gas technology. Okay, this is slightly different than game, a different objective. Okay, so that's it. I'm going to finish it up with Q&A. If you have any questions or any volunteers they want to put some funding, I'll accept. Bill, it's just quiet. I think you should. No, I mean, yeah, I mean, if you have any feedbacks, anything, let me know. Looks like probably they're ready for dinner, no? Is it? No, not dinner? Okay. Okay, thank you, ladies and gentlemen. Appreciate it. Thank you for Jamie too. I've been disappeared for the last 2 meetings. Okay.
All right, now on to our official final presentation. Neil. There it is. If you'll hold that, I'll get your stuff. Oops. Oh, is that the wrong one? And what's the name of the presentation? Is it? Oh. There we go. All right, Neil, take it away.
Thank you. All right, now for something completely different. I'm a bit worried it's getting late in the day, and I'm going to talk about seismic and geophysics and velocities, and normally all drillers just glaze over and switch off as soon as those words are mentioned.
Not this one.
Not this one, no, because it says positioning in it, which should excite you all.
He's not a driller.
Yeah, well, go easy on me. So my background, I studied as an aircraft engineer, then somehow ended up in Western GECO doing 3D marine seismic acquisition and processing. So I spent 4 years offshore there. Then came to with Schlumberger to help them with seismic LWD tool, and then spent another 4 years in Gulf of Mexico and other places, offshore field testing and working with that tool, and also doing MWD, LWD engineer. And so I've been now with this LWD seismic tool for the last 20 years, different places around the world. So we've got a new application which could be useful and interesting. So I'm interested in your feedback. So I'll do a very quick intro to LWD seismic, otherwise known as seismic well drilling. Look at there's a lateral wellbore positioning possible use using seismic travel time. We've got some model examples and results in a case study. So the tool is just a LWD tool, relatively short at 14 feet, and can be used in any hole size above 8.38 at any hole angle. And there it is. Inside, it's got some geophones and hydrophones, so that the geophones are sensitive to physical motion, and hydrophones sensitive to pressure. Then we've got air guns, which are deployed from the rig in this case, and then when we do make a connection, that's a good time to acquire seismic. So this is a little video of what's going on. So basically, we've got this tool down there, and it's trying to listen for these guns going off several kilometers or miles away. So it needs to be a very quiet, acoustically quiet environment. So while we're making a drilling connection, the pipes and slips, we're not pumping, we're not rotating, everything's stationary and quiet down there, so that's a good time to listen. And so while the connection is being made, we fire the guns several times to stack the data to increase the signal to noise. And the time it takes us to fire off several shots at 15-second interval there's normally plenty of time within the connection time to do that. So in that case, it doesn't take any rig time to do the acquisition. So then we get our measurement where the energy travels down to the tool. So the blue line there, that shows the, yeah, there we go. The blue lines, we've got travel time. So we're basically measuring the time it takes energy to get from there to there. And then also we can get some reflection data for look ahead, if we want that. That data is then, stack data is assembled in the tool. And then as we drill via MWD, this comes back to the surface here. And we can use that for, look ahead to geostop above a reservoir and that kind of thing. But that's just what we classically use it for. So now we'll get on to more interesting. Oh yeah, also we can deploy it from a vessel. So here's a little video of a vessel with some guns over the side popping away. Typically, we're maintaining a position directly above the wellbore here. On that vessel, we need to know where this gun is, exactly the time that we fire. So we have basically some surveyors on the boat with some GPS positioning equipment. So it's pretty accurate. We've got differential GPS on. We've got like sub-meter accuracy of the shot point locations. So it's in the same way that we use GPS, we figure out where we are on the Earth by using the travel time from several satellites to triangulate our position. Then why not try to do the same in the subsurface using seismic waves? So similar principle. So in essence, the proposed technique is quite simple. We'll look at it in a bit more detail in a minute. But basically, if you measure the travel time from several different locations at surface, directly above this, this is a pit coming towards us, and we plot those travel times, then this is increasing travel time going down. Then the shortest travel time is where we would expect to be closest to the well. So the thinking of this is sometimes, especially ERD, we see the EOU get quite wide. So could this be useful to basically collapse this EOU down, and then we go back to normal surveying, and then maybe do it again, do it again, do it again. So my colleague, who can't be here today, Ludovine Urani, she's a geophysicist, and she did some modeling here. So what we've got is a velocity model from the 3D seismic. And the 3D seismic is basically where we decide to position the well in the first place. And for several points along the well trajectory, we've got positions A, B, C, and D. We've got two well trajectories here, one at 2,000 meters TBD and one at 3,000 meters TBD. And we can put our air guns, if you like, at all these yellow points, and we can model, what the travel times are, and make this curve and see what the result is versus what the reality is. So we can basically test the sensitivity of this method using real data. So this is the 3,000 meter well. It's going into the screen that way. These are the different points along the well. So we've got lots of different offsets above, different spacing. And then when we model those times, we draw this curve, and then we figure out where's the top of the curve versus where the well actually is, and what's the error. Well, all these numbers here, basically, you can't see the color coding very well, but there's some green and some amber. And so we've got this shows the sensitivity using different spacing between the shots. So if we just take 7 points, and we space them, say, 200 meters apart, or 400 meters apart, or 600, etc. It's along here. For each of the positions, this is the resulting error. So there's a range of from 0 to down here, it's like 73. This is meters, by the way, down to 73 meters, but the majority of it's within less than 10 meters where we have in the green here. I think all the green is within 5 meters. Then we do the same thing for the other well at a different depth. This is basically to explore if you're going to do this survey, what's the optimum spacing to do the acquisition. This one's a lot a lot more green with the shallower one. And again, all the green is within basically 0 to 3 or 4 meters. There's a few outliers, but from this it's not highly sensitive in this case, and you should expect to get good results. So this is doing this line that we're doing is at 90 degrees to the direction of the well. So maybe different azimuth could have an impact. So again, it's just another test there to see if there's an optimum azimuth. In this case, there's this one here where we've got it's a result of about 2-3 meters error. And then the last thing is to do this practically, and ideally we want to do everything without using any rig time. So if you can imagine having a receiver in one position downhole, and then moving a vessel here, shooting here, moving over there, moving over there, moving over there, moving over there, whereas maybe moving a couple of kilometers, that would take time. So what if we do our first point this MD with our receiver over, with our boat over here, and then we shoot it, and as we're drilling, we send up the data, and the boat moves to the next point. At the next connection, we shoot again. So the receiver isn't in exactly the same position, but it's moving along a line, and if you work out the angles, it's not sensitive in that direction. So the results, come out very, very similar as if you just had a stationary receiver. So if you look at this in a bit more detail, so here we have our vessel, and it's got a position XYZ, and we have our downhole well. So we've got the bit coming out towards us. And the actual position here is XYZ is 0, 8, and 15. And the travel time is 827 milliseconds. And we plot that on here. There we go, 0, 827. Then we move the vessel 200 meters off to the side, record 831 milliseconds, plot that, 846, plot that, and we do the same on the other side as well. Then we basically fit a curve to these 5 points, and we've got an answer of 3.4 meters, when in reality it's actually 0, but 3.4 is not bad. And there's probably, I don't know, maybe 5 meters, plus minus 5 meters uncertainty on that. Then what if we do this same experiment again, but actually the well is now somewhere else. We think it's in the middle, but actually if we move the well over here, and we do the same thing again, now we get this curve, and we look at where the top of the curve is, and the well has actually moved 150 meters off to the side here, and the survey result is 158, so we have an 8-meter error in that case. And then again, if we move it the other way, we get a 2-meter error for this model. So the next case study is taking some real data from a well. So this was actually acquired through Wireline for a Wireline walk-away survey for anisotropy or something like that. But the data set's valid. It's basically we have a downhole position in the well, and we have a boat sailing across the top shooting. So it shot loads and loads of shots, which are all of these. But we'll just pick out several points, like say 5 or 7 points like we showed before. And we calculate where we believe the well is based off the curve. and the error is down here. It's 2.27 meters away from where the well actually is in the Y direction, assuming you're going north. So, so it's quite simple in theory, and I've got a little video here, which I think is playing. Yeah, and this just tries to illustrate how this might happen in a more practical way. So we've got a drill ship, we've got a vessel, and down here somewhere we should have our VHA. So in there we've got the seismic LWD tool, and in there you've got the geophone and the hydrophone. So for the geophone, when we set off the air guns, that puts a pressure wave into the earth, basically shakes the earth, that's why it's called seismic. That shakes the wellbore, that shakes the tool, that shakes the sensor, and we record the response. Also, the energy comes through, shakes the wellbore, goes into the mud, causes a pressure wave, which the hydrophone picks up. So we're drilling horizontally here, our ellipsoids drawn laterally. And then if we want to take a point, we bring out the boat. Then as we're making the drilling connection and we go into slips, everything is now stationary and quiet down hole. Even with rig heave, actually on the horizontals, the pipe doesn't move at all because of the drag. So it's excellent low noise conditions. So while that connection's happening, we fire the shots, and then we record that position. So we're looking at it in west versus east for a well drilling north, and we've got the recorded time here. And we drill ahead to the next point, next connection, shoot again, go to the next one here, drill down the next stand, move the boat, so on and so forth. So we're getting like 5 different offset points, 200 meters or more. I mean, a boat can move as far as you like, basically, in the time it takes to drill a stand. And then after drilling, I don't know, if it's a 30-meter stand, we've drilled 120 meters. And now we can reduce this uncertainty here. So I've got like 10 to 20 meters. That's playing it safe, I would say. Then, as we've done a survey, we reduce the error a bit, and then we go out to drill. That's the theory, anyway. So why would you do this? Obviously, well, I guess what I showed you there is for absolute positioning with an XYZ. But also, if you did this in one well, and then you did the same survey from the same points in another well, then you've got the relative position. So if you're in you've got a very complex overburden, that could cause some complication. But even if you have a somewhat complex overburden, any errors in the absolute position that you see in one well will be the same for the next well, assuming it's not too far away. So the relative positioning could be quite good. And then that would obviously help if you want to put lots of wells close together. So one of the challenges and most obvious questions is you've got these big boats, and big boats are expensive. And to have them hanging around all the time that you're drilling, there's a bit of a trade-off of cost versus benefit. So, but I mean, right now, I just searched the internet, saw this guy, don't know anything about this company, but we've got lots of marine drones out there now. And the type of gun equipment that we use for our borehole seismic is usually for VSP surveys, which is where we're trying to get reflections from below for look ahead, things like that, which requires a lot of energy. But for the positioning, we just need the first energy. And so here, this is like a waveform. This is where we're recording silence, and the energy arrives. Get a little wiggle, like what you see on the needle on the earthquakes, when the earthquake first arrives. And so we've got our energy here. So this is from a gun array with 6 guns, which needs a lot of equipment. And this is from the same thing with just 1 gun active. And because the noise is so low, once we start getting high deviation, we can just use 1 gun. And you could easily deploy 1 gun on an autonomous machine like this. You don't need a massive vessel, it's simply overkill. So to conclude, it's a seismic LWD. We use it for mainly depth uncertainty rather than positioning uncertainty. And it's pretty mature. I've been playing with it for 20 years now. So the modeling shows we can reduce this lateral uncertainty. It's best used where it's relatively flat overburden for absolute position. But if it's a bit more complex, maybe just the relative position might be more appropriate. So yeah, with the relative position, that should be quite robust. As any errors in the position are going to be similar for both wells. The first test of this was horizontal well in October 2022. In fact, I've just got the data on my laptop now. Fortunately, not been able to. It looks good, but we haven't come out with the results yet. So it's unfortunate. It was a little bit too late for that. But that was with a survey that we did with Equinor in Norway. We were just doing a normal VSP walk above in a horizontal well. So while doing it, we thought, okay, let's give this a shot, see how it looks. So yeah, so maybe in the future there's potential to increase the efficiency and reduce costs if we can, deploy that guns efficiently, or if you have a vessel that's hanging around anyway. That's it. Any questions?
Hi, John McMahon. So it was all of it was done perpendicular to the wellbore.
Yeah.
Was the depth uncertainty ever explored? And is it the only reason you can't try to do both? That you're trying to do it while they're still drilling, so it's obviously moving forward.
Yeah, you could. You could do all around, right, and get that position. And the way that we validate the measurement is at a point where the position uncertainty of the well is small, through the surveying. Then at that point we would do the survey with the vessel and hopefully get the same answer. And then that's good. And there's no massive changes in the overburden for the rest of the well. And you could go 20 miles and do it again and have the same, same confidence in the accuracy. So, but you could. I don't think will really help with the error ellipse much because it's where it's wide we can help the most. That's why it's focused on that.
Hey, Mike with Base Center. Just to ask about the uncertainty values you quoted. So the plus or minus 5 meters, is that including the movement of the source, or is that just the uncertainty in the data?
So I said that's the limit. So this is assuming we have a source position that we know it's within 1 meter at the surface. And then the next uncertainty is in the travel time and how well we can measure that. So if we have, say, 1 millisecond error, then if you've got a formation that's 3,000 meters per second, that's a 3 meter error. So it depends on, so in salt, you would have a higher one than a slower formation. So.
And has it been used in land seismic or just in?
So primarily this service has been used offshore. There has been some land wells. There's no reason you couldn't use it on land. There are land seismic sources that could be deployed. I think the major, I think within the industry, the smallest seismic LWD tool is 6 3/4 inch collar. So a lot of the land wells are 6-inch hole.
I know, like up in Canada, like the thermal wells, they're often like the 222 millimeter laterals that the pool can be deployed in those ones. So. And they're quite shallow too, so you probably have pretty good signal waters there. So, thanks.
Yeah, Ezra Lazardia. So can you geosteer with this also?
Well, I guess it could help. I mean, we've had some operators, come to us with a well that's he's got a target like this big, but his ellipse is that big. So yeah, in that respect, if the driller's target's smaller, then yeah, you could use it to guide it, of course.
Mark, the feed. I guess I'm just curious because seismic as a field is notorious for generating enormous amounts of data, and MWD as a field is notorious for being unable to send large amounts of data. How does that conflict get resolved in these kind of workflows?
Yeah, so the perception for seismic is massive. When I was working with the offshore marine seismic, we had these 20 gigabyte tapes, which were massive 20 years ago, and we'd have a crate stacked with them. So we'd have a lot of data. Now the surveys are in petabytes and what have you. But for this little seismic waveform that we're sending up, it's one little wiggle, and if we compress it, it's about 10 kilobytes. But for the actual MWD mud pulse, it's really not a problem. It's actually we'd use maybe, for a typical well, we use maybe like between 10 and 20% of the MWD backbone for the seismic. Yeah. So. And that's with mud pulse and not drill pipe or anything else. Okay. Thanks for not falling asleep.
Well, that will conclude all of the, I guess, preset presentations. Now it's, I guess, the end of it for subcommittee chairs and I guess Adrian to any other questions that we have set.
So we set aside some time if there is any question that was not answered to either presenters or the subcommittee. Anything that we would like to discuss, otherwise we'll go ahead and adjourn. Robert?
Robert Estes with Halliburton. I've got a question I can throw out to Benny, if he didn't have enough questions. Okay?
Question for me, okay.
On ranging,
Okay.
one of the things I learned, one of the things I learned 20 years ago with the introduction of first gyro into the is that producing wells are noisy. You did not mention passive acoustic ranging as a means of locating and homing in on a relief well operation. Is that a potential thing to do?
Yes, in the ebook I mentioned that specifically using the noise, listening to the drilling noise on the DHA from the project. Yes, I mentioned in the ebook, but I didn't use this in the presentation.
Right. Okay.
There's a lot of developments that we can do. For example, I'm trying to get the acoustic do something the data on the
seismic, it's a premise. What we're trying to achieve here is time. It's not a waveform, okay? On the acoustic engine, we send waveform, and it's a bunch of receiver, right? 107 receiver data in one go, in one click. You want to do that many click and do this. And we'll do them kind of, okay? So keep in my position.
Thank you.
That's it? That's it. Come on, give me more. No, that's it. Yeah, this, the last presentation is assuming that the upper burden is flat in order to have an estimate of the position. So what happens if the seat bottom is not flat? It's seismic that we don't have always a flat upper bottom. So does it work?
Yeah, so if you have a dipping, that's going to introduce a skew in the data, but then with modeling beforehand, assuming you have a velocity model, then you can know what to expect, and if it's dipping uniformly across where you want to drill, then you basically would do the survey at a point where you don't have very much uncertainty in your wellbore position, and that will basically give you the real error that you have. And then if you're willing to make some assumption, if it's fairly uniform, then when you've done 10 miles that way and you do it again, then it should be a very similar error.
Because you speak about the velocity model to estimate the error, and it's not easy to have a good velocity model. It's a lot of work.
Yeah. So that's why it's important to calibrate, if you like, and check it where you've got a low uncertainty in your wellbore position. That's the first place you want to do the survey, and that's going to take you the real error, not a model one. Yes. Yeah. Assuming there's no massive change in the formation.
I got a question. You mentioned the word calibrate, and I was just wondering, do you calibrate against gravity data? Or do you fly in given gravity data to calibrate against?
No, I'm not sure how.
Well, you could use gravity data to calibrate the elevation, right? And then you can do that, they calibrate the seismic depth by overlaying gravity. So have you ever tested that out with some gravity data?
No, not done. That. All right. I don't know for you, but it's been a long week, so I think if there is nothing to keep us going, we'll just call it to a close. So first, I would like to thank again, have a long list, but start with the K&M for all the work, for providing this facility and sorting out all the details of the rooms and the lunch and all that. So thank you very much. I'd like to thank as well Charodata for paying for yesterday networking event at St. Arnold's. Of course, the presenters, I know everybody has a day job, and putting together a presentation is not usually so easy and prepare for this, so I appreciate that, the same as with the panelists coming here and travel, so thank you very much. Also for the subcommittee chairs, also the guys are very busy and appreciate the effort to, come yesterday, have the meeting and work last night to put together a presentation to what we discussed yesterday. So after the networking event and probably dinner, so thanks very much for doing that in time. Again, Mahmoud, thank you for your help with the registration, setting everything up.
and Carol, she was, instrumental for the election to run smoothly. So thanks very much for that. We'd like to thank Hans as well for putting the program together. He's not here, but he worked hard and contacted the presenter and evaluated the different options that we have. So thank you very much, Hans, and also David Gibson for coming and help with the program and setting up the camera for if I don't know if the live went well or not, but it did. Excellent. Otherwise, we at least have also a recorded that we can take a look afterwards for the president. Maybe, yeah.
Just want to censor what it will be saying that? You want to censor? Anything?
And finally, well, thanks everyone for joining, for either traveling or being here, making the time to come here for this first event since 2019 live. So appreciate that and thanks very much. The last thing, which we usually do, the next meeting, we had a conversation a couple of days ago. We're going to aim to have the next meeting coinciding with IADC that week in Stavanger. So that's the plan. We're going to contact some operators, see if we can get some sponsors for a room or for, well, any help that we can get and move it to Europe, so we give a chance to the people that live on that side of the world to travel less. And that's all. Thanks very much.
Thank you to Jared Data for the mixer last night.
Thanks.